know you're using the sheet?
Yes, but he doesn't know how we're using the sheet.
Yeah. He always knows when someone's using the sheet.
Which kind of sucks because he's not here.
Yeah, why is he not here?
Good question.
Yeah. We can't figure out why he's not here.
Uh-oh. He's still looking for his goals.
He's still looking for a sheet.
Not even in town.
Lance
He's that good.
is a member of DC 801 and works in the payment card industry. He develops and maintains APIs for his job and enjoys writing code. Lance works with open source systems and is an avid Linux buff. Lance's area of expertise is Linux system administration, software development, and computer networking. He's going to talk about IRC bots.
Well, apparently I don't know how to use PowerPoint. Slideshow, right?
We didn't list PowerPoint as one of his skills.
Okay.
Forgive him.
All right. This is going to be very code-centric talk. I tried to boil down the code as simple as possible. So I'm going to talk about writing an IRC bot and just kind of the very simple methods and simple parsing, and all the code is on here. I try to create a bunch of really simple examples for each idea, and then I have a complete bot. There is a bot in there called command bot. I will warn you that if you run that, it'll actually let people on IRC run commands on your system if it's in a Linux environment. So don't run that bot.
So put it on other people's systems.
Yeah. Alright, so if you don't want to pay attention, you can just go get FennyBot. It's a complete bot. I started working when I first started, I started working with that. I didn't like it because it kind of felt like it did everything for me, and I wasn't understanding how IRC worked or how anything really worked. So I kind of just dropped it because I wanted to write my own very simple bot. And here's some others in some different languages. I didn't look at Cinch very well, but that looked like a nice framework for Ruby. There's also Egg Drop. That one came up a lot in my searches. It's written in C. I don't know exactly what it does, but it seems pretty popular.
Yeah, it's OG.
OG. And if you want a list of all, the bots and their comparisons, there's a nice wiki page that gives you all kinds of details. So the question is, why would you really want to write a IRC bot? Well, yeah, I don't know. They're kind of lame, but they're also kind of cool too. The nice thing is they're simple, and that you can interface with people. Like when you connect to IRC, you can interface with lots of people and get your code connected.
Is there a way you could reference a farm animal and have that send a text message with the bot?
Yes, we will cover that.
Okay.
Yeah! We will cover that.
Can we test it?
Yeah. Go for it.
Done deal.
My phone number is 911.
So kind of some ideas. I wanted to get an Arduino bot going. I didn't have time to finish one. But if you just tie in Pi serial, you could plug your Arduino in, bring up the serial port, and then bam, you can turn your lights on and off from IRC, or whatever you want to do. There's also an example of Speaking Bot. It's also on my GitHub. I'll go over that. It's kind of a cool bot I wrote where I'll actually, it'll use voice, text to voice, and you can audio representation of what's going on in IRC. I have a command and control bot in there that we'll go over. It's just very simple. Another nice thing about IRC is just the ability to send messages and receive messages. So like if you want something on your network to notify you, while you're working, you can have it go in IRC, and not only could it notify you, but it could notify everybody in that IRC. All right, so this is Nemus bot. That's the code that's actually running in the DC 801. I published that. These are kind of the basics of an IRC bot. So you have a socket connection, and then you join a channel, and then you either run, if you check for an identity or you enter credentials, then you enter a while loop, and then you just parse messages and execute commands. So this is a very simple UDP socket client. You can see here we just import the sockets for Python, set the IP address, set a port, we have a message. When we go here, the AF.NET means IP version 4. This is a sock diagram meaning UDP. And then we just say sock message IP port and send the message. Here's the server. All the server does is listen, so it says I'm going to listen on UDP port 5500 or 5005. And then I'm going to sit in a while loop while true, so I'm going to sit there forever until the process is killed. Then I'm going to receive 1024 bytes, and put it into data and print the message. So that's UDP. This is the same thing in TCP. IRC runs on TCP, so you're going to set up a TCP socket. Here's the server for TCP. So it kind of gives you a feel of how the sockets are communicating and how Python's interpreting it. So another thing is eventually when you get more advanced into this, you're going to want to probably use non-blocking sockets. So when you set up a connection, it's going to sit there and wait for data on the socket, so that so nothing else is going to happen until it gets data. So if you want to check for timeouts or your bot fails or something like that, you want to go into non-blocking sockets, and that way it'll check every once in a while. And then if there isn't any data, it just throws an error, and you can catch the exception, or you can use the select method. Here's the select method. So basically what it'll do is it'll pull all the open sockets and get all the data that needs to be read or written to, or any errors that are on the sockets, and then you can handle them individually.
How often does it pull?
You can have it pull as much as you want. You can run it in a loop. Basically when it's in non-blocking mode, you're just basically like, do you have data? Do you have data? Do you have data? Okay, I'm going to go do something else. Do you have data? Okay, I'm going to go do something else. With blocking sockets, you're like, okay, I'm going to sit here and wait for data, and nothing else is going to happen. So all my examples use blocking sockets. The issue with that is for disconnect, because when the disconnects, I have to wait for a timeout. That can usually be very time consuming. So if the internet goes down and the connection goes down, it takes about 5-6 minutes for the bot to realize, hey, I've lost my connection. I need to go back. Whereas IRC sends a ping, I'll talk about ping later, where if you check for the pings and if you haven't received a ping for a while, you know that you've lost your connection. Alright, so this is what it kind of looks like. So we're just going to connect to an IRC server, Freenode, and this is the output. So you're going to see a whole bunch of messages here. And so the next thing we need to do is we need to parse these messages. Here's the IRC, so get started. Actually, the IRC is very well written. I only use it for reference, but you go in there, you type in the number or the message, and it'll tell you, hey, this is what this message is supposed to mean, and this is how you're supposed to handle it. It's a pretty nice protocol, and then here's an example where you can kind of do IRC over Telnet. But this is the basic message format for IRC commands. So you have the prefix, the command, the parameters for that command, and the trailing. The trailing is your actual message. So we'll go over that. So first we'll start with the prefix. The prefix pretty much represents the origin of the message. In this example, we're seeing a ping from the server. There is no prefix here. Yeah, there's no prefix in that first ping command, but we do see one here at the bottom with the notice. So we're saying that this message came from freenode.net notice, looking up your host name. So this portion right here is the prefix, is the location. This would be the command, and then this is the trailing, this is the message. So this would be something, if you're writing an IRC client, this would be something you print to the user. And then here's the command parameters. So here's a couple of examples. The private message, quit, join, mode, and ping. These are basically what you're going to do with the message, or how the bot's going to respond. So basically with the quit and join, so if you want to keep track of who's in the channel and who's coming and going, and you want to keep that state in memory, you keep track of the quit and join commands and then update your users list accordingly. There are also numeric commands. Those are usually received when you send a command back. You get back a numeric command. Like this command 443. This name is already in use. You'll get that a lot when trying to pick a name on Freenode. So that's something you're going to probably want to program for. Because if you're going to put a bot on something, or you want to put a bot maybe as a back door, you're going to want a unique name, and you're going to want to be able to handle the fact that that name might be already used. And then the parameters, basically they're just kind of additional settings for the command. So like, just basically like a command like ls, you do the ls space dash ALAH or something like that. Just additional parameters. So the trail is an interesting end. So it starts with a colon and it goes all the way to the end. This is where your actual message from the person who's trying to send you a message comes in. So this is where the actual text when you type your sentence in. And so because it starts with a second colon and a space and then goes on to the end, it can contain any amount of text variant that you want. Parsing, this is where you're going to want to build your commands. So you're going to you want to get the trail, and then you're going to put your own commands in the trail. All right, and so this is a regular expression for parsing an IRC message. I got this off a website, and I kind of tweaked it a little bit to work with IRC. But it'll give you all the params, the prefix, the commands, the params, and the trail. And then this is a code parsing version. It gives you the prefix RX command. I need to update it too. The trail isn't actually sent back in the return statement. The reason why you want to use code parsing versus regex, it just depends on how many commands you're working. The regex engine is going to run a little bit slower than just the standard code version. I haven't really tested it, so I've been kind of playing with both. They both seem fine. So then we go back to sheeping lean.
Yeah.
So Metacortex wrote this regular expression to listen on DC801 for any variation of sheep that we could think of. And anytime we see the word sheep in IRC, we send a message to lean letting him know that somebody's talking about sheep.
Over SMS.
Yes.
Which channel is this on again?
DC801.
DC801.
BRB.
So the way I send the text message is I do vtext. If you know the carrier, you can send the number an actual text message by email. So all you really need is an open SMTP server. So here I just say, hey, send an email, and I say sheep alarm sheep, and he gets a text message.
At 4 in the morning.
Yes.
Cron job.
So are you still blocked by Verizon, or did that get unblocked?
I actually went through the process of registering my mail server as a legitimate source and doing the R record and all that stuff, so I wouldn't show up in spam records.
Does your bot come with like a disclaimer like standard messaging rates may apply?
It's text. It's the person getting them, not the person sending them. So.
Right, like if the message that gets sent, you're like, Lean, somebody said sheep. Standard messaging rates may apply.
Yeah, luckily he upgraded to unlimited texting.
That was pretty quick after you made the bot too, if I recall.
Yeah, he jumped on that fast. Alright, so on the code there is basic bot. This is the most basic IRC bot you can build. So here we have necessary libraries, socket and time, the server, channel, botnet, nicknames, host name. These are just all variables you need to set as you connect. These are kind of the static variables. So here's the ping command. So IRCs, every once in a while, it wants to know if you are alive. So it's going to send you a ping. and you need to respond with a pong. If you don't respond with a pong, it's going to assume you're dead, and it's going to say your connection's closed. So this is great because it allows you to measure how much connectivity you have to the server. These come about every minute or so. And then also, so you're going to respond to pings, and then you're going to join channel, and you're going to send messages. And this bot, all it does, the only command it parses is hello. So I'll show you here is how it actually connects. So we're going to connect to the server. We're going to tell it, hey, this is my NIC, and then I'm going to join the channel. So I'm going to join the channel that we showed earlier. And then this is the while loop that's going to parse incoming messages. So here I'm going to listen on our socket for 248 bytes of text or whatever. I'm going to strip out any unnecessary line breaks. I'm going to print the message to the screen just because I want to see what it is. And then if we see the word hello space our bot nickname, we're going to respond with hello. If we see ping anywhere, so we're going to do a find anywhere in this text where it says ping space colon, and then I'm going to respond with an actual ping. So now we have a bot that's connected to IRC, that's receiving messages, sending messages. We basically have everything we need to connect and run on IRC. So at this point, you're going to probably want to spawn a background process for your bot, because you don't want it running in your foreground all the time, because you probably go doing other things. So we're just going to go over forking. So basically when you fork a process, what you're doing is you're creating a complete copy of the running process. And so I'm going to show an example where we're going to daemonize our bot, and we're going to fork it, we're going to kill the parent process, and then we're going to have the child process run. And it's going to run the bot for us in the background so that we don't have to worry about keeping a terminal session open or running the programming screen. Then here's some code, this is really basic forking, just to show you how it works and what it does. So one process is a child, the other process is the parent. If the PID equals 0, it's a child, else it must be the parent. So if you run this code, it'll say, okay, I'm the child, I'm the parent. So luckily, you don't need to really know anything about forking processes. There's a great daemon class library. It's right here. This code shows you how to use the daemon class library. So all you do is inherit the daemon class, and then all you got to do is overwrite the run function and then put your while loop. So here would be your while loop where you run your bot code, and that'll run it in the background. So I'm going to go over kind of the SpeakBot. SpeakBot is an example of doing very simple inter-process communication. So SpeakBot runs inter-process communication through SQLite 3. SQLite is a great little program. Their motto is they're not a replacement for a rational database, they're a replacement for fopen. So if you want to run a process and have the two speak to each other, you can do that through a database. So basically I have the IRC process, open up a database, write to a table, and then I have this process which actually does the audio out. The reason I do this is because we can read and type a lot faster than this thing can actually talk. I don't know if you've been to DC801. We have SpeakBot running on a Raspberry Pi there. So people talking the IRC, we can actually hear what they're saying without actually having to look at the IRC channel. So here's the basic code for SQLite. Basically, I create a table. Here, I have auto increment, and I just put the handle and the text, the channel, and the message in there. And so every time I get a message, I just insert it. Also, SQL safety and parameterizing. Then here's the code for SpeakingBot. Okay, so this process is a different process. So I'm running two processes here. So I have the IRC bot, which actually takes the data in, takes the message in, and then I have SpeakBot where it actually goes to the queue, and then SQLite acts as the buffer. So SpeakBot will go through the buffer and then read all the text and display it out in audio. So another thing that's kind of nice about bots is you can have them do curl calls and return data. Here's a basic curl call. So let's say you want to keep track of how much Bitcoin is, but Mt. Gox is down or their website's being DDoSed.
Yes.
Yeah. So here I was using another URL for a different site for data, but it stopped working, so I just switched back to the Mt. Gox API. Basically what this does is it pulls the API, gets the data, and returns it in JSON format, and then displays it out. Alright, so here we go, executing command. So for SpeakBot, I just did the os.system ls, that will run a command. But the problem with that is it's going to as standard out. There's no real good way to get the text back. So here, this way, if I want to actually get the text back and display it in IRC, I'm opening up a sub-process, and I'm just passing it an array here of commands. So that'll actually run the ls-la and tell me all the files that are on the system. And then this is the command function. So here I'm doing a regex of the message. I'm getting the trail, which is the group 6. I'm splitting the command. I'm removing the first part of the trail, which is the run command. If you look in the code, so basically you do :run space run any command, and then we'll parse out that message in the trail. So I'm removing the :run there. I'm printing the command, and then I'm actually running the command on the system. And then once the command's done, I'm displaying the output to channel. So another part is so maybe you want to run commands to an IRC bot, but you don't want everybody in the world to do that. One way you can prevent other people from running commands on a bot you have it running on a remote system is you can do an authorized signature. So basically what we're doing here is we're going to send a request to the bot, and we're going to sign it with a salt. So the salt will be a secret that I know and the bot knows, but it's not being transmitted across the network. And so what I'm going to do is I'm going to put a timestamp inside that string, and then I'm going to put the command that I want to do, and then I'm going to run that through, I'm going to add a salt, and then I'm going to run that through a SHA-1 protection. The reason why I use SHA-1 is because it generated a shorter string. And I didn't, IRC will only take so much text before it'll start breaking it down into 2 commands. I didn't want to parse 2 commands. So here it'll go through, generate a string, generate a signature, send the signature, and then the other part of the code will parse the signature, validate that the signature is actually valid, say, okay, yeah, I can run this command. So this is a way you could have authorization on your bot to run commands, and that way other people, it would be really hard for them to reverse this. Although they could reverse it if they want, if they can find a collision. I'm sure there's ways to get around it. And then this is encryption. Basically, so if you want your bot to return encrypted data, here's just a simple version of GPG. So you want to generate a GPG key, generate a private key, and then you can have that data encrypted with the key and have the bot send back the data. So there's code in there to do that. So basically that's pretty much it for IRC bots. Those are some of the simple things you can do. One of the things that I wanted to do, so the main reason I started writing IRC bots is because I wanted to understand how botnets worked. And I wanted to kind of start from the ground up, and kind of get my own perspective of how botnets work. So I was like, all right, well the first part would obviously be looking into the IRC protocol, seeing how that functions, and seeing how hard it would be to actually write an IRC bot. Next phase, I think, will be a worm. I want to write kind of a basic worm in Python that'll just go through brute force SSH, maybe brute force VNC, maybe go after some R desktop, just something that I could run maybe during a CTF, because nobody wants to sit there and brute force a bunch of SSH, but it might be a good way to get into a system. So I was thinking I could write a worm that would go through a network and just brute force all the basic passwords, brute force all the basic authentication, and then send back a report saying, hey, I got in here, I propagated here, and then maybe go and install an IRC bot, come back, talk to me, then I can go through and run commands. So that'd probably, this will be my next thing that I do. This is another great paper I found for SANS. It goes over building your own botnet. It's written in Java. I haven't had time to really read it. I kind of came across it while I was doing research for this talk. But if you're interested in learning more about botnets, this would be good. Over here too, there's a really good writing worms for fun and profit talk from 2006. It's probably a little bit outdated, but I'm sure there's some good information in there. I kind of just looked at it, went through it a little bit. And that is it.